The interval scale has a definite ordering. However, we can't calculate the differences between the data because it doesn't have the differences between. So the interval data scale has a definite ordering, and the differences between different data points can be measured. However, interval data doesn't have a starting point. Let me say that again. Interval data doesn't have a starting point. The only two main examples we're going to see of interval data are temperature and time. Now we have a theoretical absolute zero, like the coldest temperature you can get. I think it's negative 273 Kelvin, fun fact. But we don't really have a starting point for temperature. Same thing with time. We don't really have a starting point for time. So for example, on temperature scales like Celsius and Fahrenheit, even though there are zeros on both of those scales, we can also have negative temperature. We can calculate the differences in data. So for example, 80 degrees Fahrenheit is 60 degrees Fahrenheit warmer than 20 degrees Fahrenheit, but we cannot create a ratio of this data. We can't say 20 degrees Fahrenheit is a fourth as cold as 80 degrees Fahrenheit, or 80 degrees Fahrenheit is 4 times warmer than 20 degrees Fahrenheit. We can't say that. All right, so we have our nominal level of measurement, which is the simplest and only applies to variables that can be organized into categories. We have, for example, that could be your favorite colors. We have ordinal level of measurement, where we can describe data with a ranking or ordering scheme, such as ratings of movies or restaurants, 1 to 5 stars. Then we have, last but not least, the ratio scale. The ratio scale is data that can be compared because it has a 0 point. It has a point where it starts, whereas temperature and time did not. Ratios can be calculated, which is exciting. So for example, if a test scores out of 100 points and we have scores of 20, 68, 50, 49, and 98, and 80, we can say that 98 is twice as much as 49 because we have a 0 point. We can also compare differences. We can say that 50 is more than 20 by 30 points. We can also say that 20 is 1/4 of 80, all because we have this 0 point. And thank goodness no one got a 0 on this imaginary exam I made up. So this is a table, you'll find it in your book. I think it's figure 2.1. And what it is a comparison of the levels of measurement. So for qualitative data, you can have nominal data, such as eye color, or ordinal data, such as a rating scale. For quantitative data, that data can be discrete, right? Meaning it's counted or only takes on fixed values. Or continuous, which means it's measured. So let's start with continuous. So for continuous data, if it's measured, we could take interval data, would be temperature, right? We can measure temperature. And ratio would be height, right? That's something we measure. For discrete data that we're counting that doesn't have a 0 point, we can go with shoe size. Like you can't say a size 5 is half as small as a size 10, right? That doesn't make sense. And there's no shoe size 0 to my knowledge. But ratio data, stuff we compare, could be exam scores because it does have a 0 point. And exam scores typically only take on full values or half values. Wonderful. So here's a summary of the 4 levels of measurement, just to help you keep them clear in your mind. So let's identify the level of measurement as nominal, ordinal, interval, or ratio for each of the following sets of data. The first thing I like to do is determine, okay, is this qualitative or is this quantitative? Because if it's qualitative, I already can cross out 2. If it's quantitative, I can cross out the other 2. So let's take a look at this. Numbers on uniforms that identify players on a team. This is a little tricky, right? Because that numerical value on the back of their jersey is used as their identifier, right? What else is on the back of a uniform? A name, right? So this isn't interval or ratio data. This is actually qualitative data. Because that numerical value has no real meaning, except maybe personally to that person, like their favorite number or something. And this would be nominal. Student rankings of cafeteria food as excellent, good, fair, or poor. So they're rating them in words. So I know this is going to be qualitative. And it's not nominal because there's a set order to it. It is ordinal. Ordinal like it has an order. That's how I remember it. Calendar years of historic events such as 1776, 1945, or 2001. Well, this is quantitative data. Something we counted. It's discrete. It's also discrete. I didn't ask for that, but we're going to put it down anyway. It's discrete. But it's going to be interval. It's interval because temperature and time don't have a starting point. So we've got interval quantitative data that's also discrete. There's 3 different ways to describe this. On the homework, if it's asking you just for interval, don't feel like you need to answer everything. I'm just trying to make sure that we're all on the same page and we do a little refresher every time. Temperatures on the Celsius scale, that's quantitative. And that's also interval because you cannot, you don't have a real 0. You can't take a ratio. So temperature and time are always interval. Key takeaway. Runners' times in the Boston Marathon. That starts with 0, right? Time 0. So it's quantitative. And even though it's time, see, this is a tricky one. Even though it's time, and I've said, wait, time doesn't have a starting 0 point. I mean like time doesn't have a starting 0 point. If we're timing how long it takes to bake a cake or run a 5K or run the Boston Marathon, which is way more than a 5K, that's going to be ratio because there's a 0 starting point. Good for us to know. See, we didn't get tricked. We didn't get tricked by the time.